I will introduce the basic concept of the comparison test. So in the comparison test, the given series is AN. So when you solve a problem, the problem gives you a series, right? That series, we call that an AN. So to make a comparison, I need another series BN. So let's read the first line. Suppose that the sum of AN and the sum of BN are series with positive terms. There are two cases. On the left-hand side, we have case 1. If Bn is convergent. What is convergent? Convergent is the sum of Bn is equal to a real number. Let's say 10. All right. And also, An is less than Bn. Tell me, what kind of number is less than 10? Something slightly less than 10, right? So let's say 9, 6, 7, 5.5. They are less than 10. I am saying that Bn is convergent. That means whatever less than this convergent must be also convergent. So look at the arrow. An less than Bn. Bn is convergent. And then you look over to the other side. Then An must be convergent as well. Because in what kind of number is less than 10 again? Another real number, right? So that real number stands for the sum of An. Therefore, An is convergent. Case 2 on the right hand side. What if Bn is divergent? What is divergent? Divergent means the sum of Bn is equals to infinity and An is greater than Bn. So An is greater than Bn. What kind of number is greater than infinity? The answer is an even bigger positive infinity. So therefore, Bn is divergent because the sum is infinity. Look at the arrow. So what about An? Therefore, An must be divergent as well because the sum of An must be a bigger infinity. Bigger infinity stands for divergent. So that is how the comparison test works. And then I have a very simple example for you. So my primary sequence is, look at the blue sequence. We have the sum n goes from 1 to infinity of 1 divided by 2 raised to the n plus 1. So the first sequence is my An, and then the other sequence, I want to compare that with the sum of 1 divided by 2n. So what is the difference between these two sequences? The difference is the plus 1 is not in Bn, right? Why? Okay, look. The 1 divided by 2 to the n, this is a, what kind of series is this? This is a geometric series. The ratio is 1/2, right? Look, we have n goes to infinity. So when n is so big, listen to me right now. Why do I use 1 over 2 raised to the n for comparison? I am going to answer this question. Why I omit the plus 1? Listen to me right now. Look at the primary series. We have 1 divided by 2 to the n plus 1, right? When n is so big, do we really care about the 1? Again, when n is so big, do we care about the 1? The answer is no. Okay, the answer is no. So for comparison purpose, I am going to write the exact same series, but I will omit the plus 1 because when n is so big, the 1 is not important anymore. All right, but if you don't omit the 1, the primary series, that is not geometric, right? So that is not geometric. You have to omit the 1, and then we can say, all right, so after you omit the 1, this is a geometric series. And then what is the r? The r is equals to 1/2, right? So that means the absolute value of 1/2 is less than 1. We talked about geometric series in the previous lesson. What happened when the absolute value of common ratio is less than 1? The geometric series is convergent. And then which series is bigger? So now we are trying to compare the nth term, 1 divided by 2 raised to the nth power versus 1 divided by 2 raised to the nth power. Let's make a simple comparison. Just make your life easier. N starts at 1, right? Okay, just let n equals to 1. Which one is bigger? 1 is 2 plus 1. 1 is 2 in the denominator. Tell me which fraction is bigger. Of course, the 1/2 is bigger than the 1/3, right? So that means An and Bn, we say that An is less than Bn, then this is case 1 above. An is less than Bn, and Bn is convergent. So since An is less than Bn, that means An is also convergent. So when I was learning the comparison test, this is what I am thinking. All right, I got a series that is very similar to a geometric series. The only difference is you have to omit the plus 1. All right, okay, then I will make a comparison. I will write another series and then omit the plus 1, and then here is will be my comparison. For the series that I wrote, that is a geometric series, and then the common ratio is 1/2, the absolute value of 1/2 is less than 1. So I just show that Bn is convergent, a convergent geometric series. Right, so convergent geometric series. The difference between An and Bn, there is only a minor difference. So after you roll Bn, that should lead you to a test where you can quickly determine the convergence or divergence. So we have Bn, so we just determined that Bn is convergent, but you have to make a comparison. Which one is bigger? An or Bn. So to make a comparison, I let n be equals to 1, the very first term. When n is equals to 1, I can clearly prove that Bn is greater than An, so which is the second line of the inequality. 1/2 is greater than 1/3. So therefore, Bn is convergent. So what is less than, what kind of number is less than a convergent? A smaller sum, right? That means on the other side, the smaller sum is the sum of An. Therefore, An must be convergent. And that is how the comparison test works. All right, so if the comparison test doesn't work every single time, so once a while, you will see that this comparison test would not work. When the comparison test doesn't work, we have to use the limit comparison test. I will introduce that in the next video. So that will be all for this video. If you think my explanation is helpful, let me know in the comment section below. Please like, subscribe, share the video for me. Appreciate your help. I see you all in the next one. Signing out for now.